Okay, there's also a link between delta G naught and K, the equilibrium constant. Now, if you remember what the equilibrium constant is, in this instance, let's go back to the original equation. It would be K equals, it would be S2Cl2 to the fourth over S8 and Cl2 to the fourth. Now obviously we don't have these concentration values to calculate K, but we can calculate K since we already know what delta G naught is, and we calculated that down here as minus 177.0 kilojoules per mole. Alright, so let's take a look at how we would isolate that. Now we've got delta G naught equals negative RT log K. We've got to now isolate K somehow. So how do we do that? Well, what we do is we bring the negative RT over the other side. So delta G naught over negative RT equals log of K. I'll flip everything over, and I'll also bring the negative to the top. Alright, so here's the next part, is we need to take the inverse log so we can isolate K. So we take the inverse log of a log, we'll end up with K, and here we'll have inverse log, and it's inverse natural log, and inverse ln of negative delta G naught over RT. And so on the test I'll give you this equation, but you would have to derive the K equation if you didn't remember that. So the inverse log in your calculator, that is going to be e to the power of, and then what I would do, whoops, yeah, e to the power of, so yeah, a little caret like that, and whatever your negative delta G over RT turns out to be. So looking at how you would calculate that, you've got delta G naught over RT. The R has a value of 8.314 joules per mole per Kelvin. That's a constant value. And here you've got joules per mole per Kelvin, but we've got a delta G naught value that's in kilojoules per mole. So we're going to have to do a conversion of joules, of kilojoules to joules, so that these units will end up matching. So it'll be kilojoules times 1000 joules per kilojoule over 8.314 joules per mole per Kelvin times the temperature, which was given as 298 K. Now, if it's a negative delta G, then what you're looking at is always a big number for K, because the negative will cancel out the negative and you'll end up with a positive here, and you're taking the inverse log of anything, and the number that you come up with here, by the way, in your calculator would have been 71.44. And that's what I recommend, is coming up with that number, what's in here, and then taking the inverse log of that, and realizing that the inverse log of anything that's positive is usually going to be a pretty big number. And not surprisingly, if this was a negative number here, that would mean that the delta G naught was positive. If that was the case, then you'd end up with a very small number for K. So K is usually either a very large number or a very small number. Just summarizing that down here. So negative delta G leads to large value of K, because you've got e to a positive number, e to the power of a positive number. If you've got a positive delta G, you'll have e to the power of a negative number. So that's going to lead to a large number, and that leads to a small number. So it's always good to know what you're going to expect. And when I say large, I'm talking like times 10 to the power of something. And this would be times 10 to the power of negative something.